So we have this one very quickly, the second one as well, but that will go a lot faster. So we do the second class, new C++ class again. This is again show all classes, and it's, I think, simply based on actor. Let me verify. So this will be the checkpoint, base checkpoint. It's based on actor indeed. Let's just do that. Name that, create class. Now in here, let me bring in the code. So we have the game state header and the CPP file. So here's the header file of the code that I have. So if I do this correctly. So those are the things we bring in. And again, this will go very, very fast to bring things in. Here's a CPP. Do all of this, I think. I hope I don't mess up the... I'm a very good programmer, as you can see. I copy-paste stuff. It's high-end. So that should be correct there. That should be correct. Let's do the checkpoints. It's a checkpoint CPP. Let's bring this in as well. Probably brought it in the wrong one. No. That's that. I missed one file and one line somewhere. Just verify I have the right one. What's that? And then one remaining line because it has to include the other one at the top. Where am I? It's to include checkpoint in game state header. I think. But we'll see. So you can compile this in here, which would be the proper thing to do, to compile it directly from Visual Studio. But if you want to test it, you can also compile it from within the editor. It's just, that's not long term, right? That's more literally for testing it. So it's going to hot reload the code doing that. But it doesn't replace the actual original DLL files. Okay? It's just temporary. So eventually you're going to have to do a proper compile here, and it failed. What did I miss? Oh God. Line 29. So now we can go debug. Generated body. I missed copy pasted something. Line 29. What did I forget to copy paste? Oh my God. What did I forget? Base checkpoints. What did I forget? Generated body. That. Probably forgot that. Whoops. Whoops. No?
It's inside blocks.
It's in there, you mean? Yeah, okay. Sorry. I'm very, very good at this, as you can see. I'm much better at the art, which is the next step. Correct, right?
Next file 2.
What?
Next file 2.
Next file too. This one, oh God. Right? I guess. We'll find out soon enough. No, I failed again. Oh my God, I'm terrible at it. Now it failed a lot, so I missed one particular thing probably, which is some kind of include, I'm guessing. Sorry, let me just try to figure this out. Base checkpoint. Should be okay. Anyone sees what the problem is? This is an interactive workshop, right? I'm involving the public here. Anyone see what I missed? Should be it, no? Unless it's one of... No. Any idea? No?
I'm not so good in C++, but Do we need a semicolon after generated body? Maybe.
Said
No?
what? Said what?
Semicolon after generated body.
No.
Look at FM base checkpoint. Yeah, here. Do we need semicolon or
No,
not?
this one is correct. The text I have here is correct. So
Okay.
it just did a copy paste error. That's it. The code itself is correct. It's just I missed something. What did I miss? Or there's a reference somewhere or an include some. There's something like that is simply missing. Because the rest should be correct. But I don't see it either.
But just error message looks like just syntax error.
Yeah, it's just something very simple.
Yeah.
Otherwise, it's so. What? Yeah, should be correct. I think. I mean, that looks okay. That looks okay, right? The what? No, we don't have any other one either. That one is.
Look at the constructor of previous class. No.
Constructor would. Yeah.
Replace name. Yeah, it's.
We need a different basic class. No.
That is correct.
Not basic, but exactly this class. It's AFM-based
Game state.
and
Yeah.
constructor is for AFM-based checkpoint. So content.
Oh yeah, we need to replace constructor in this class. We have FM-based checkpoint instead of IFM-based game state constructor. It's line immediately after public. Yeah, this line we need different constructor. Okay, looks like you copy paste from different class whole body
could
of
be.
this class. Base checkpoint. Yeah. We need copy paste whole body there.
This?
Yeah.
But then it's going to take that, so I can't take that either. That's not the correct one.
From game state. Yeah. Look,
That one, you mean?
it's content
that's
from base checkpoint.
Second
Yeah.
one, yeah.
And in Visual Studio, you have content from base game state. Yeah, you need just replace content.
That you mean?
Yeah.
I did it wrong, yeah, okay. Sorry. High-end coding. Probably works. Third time. Yay.
Oh.
Yay. I'll move on. Just to very quickly show what it actually did is if I now go back to the checkpoint or the game state, let's do the game state, and I rebind the game state to, you said a parent class, so reparenting it to the one I just made, which is called base checkpoint, I think, FM base game states. That's the C++ one I just made. That shows up in here now. And now it's a child of that. I can access the variables and the functions that I made in there, which was, for example, increase checkpoints. So increase checkpoint, and here's my function from C++. It's that easy. I had a variable called, for example, max checkpoints and current position. Let's just take current position. You can see here's current position from C++, and it looks identical from current position from Blueprint. See, here's the Blueprint one, here's C++ one. It's that easy to just blend the two together. Same for the function. I could have made the function that I made earlier, which was that one, right? I could have made that look exactly the same as the C++ one as well. See, if I rename the names a bit, so there's basically no difference. You can go back and forth between them very easily. Cool. You want to move on, build a level? Yeah. Importing. I'm going to import a couple of basic assets first, just to show that workflow. So I'll import two models. And the two models import are the floor and the walls. So they're located in here. 2 FBX files. So we use standard FBX format, meaning everything that can handle FBX will work with Unreal. Modo, Max, Blender, Maya, anything else. Standard FBX. When you import it, you get options. I'm going to turn off something so I can show you manually what it does. Auto generate collision, nope. Generate light map UVs, nope. And don't import materials and textures. I want to do everything manual. And I advise you to do this anyway. Even if I work on real production stuff, I never have these options on. I want to have control, right? You don't want just stuff to be generated, not in this case. So I turn it off, import all, and you get your 2 models. So here's the walls of the apartment. You can see this is the Epic office, by the way. So that's their office. And there are a couple of things problematic here. It has no material, the light map is wrong, and it has no collision. So, light maps are easy. I can show the UVs of it, which doesn't work very well here, and that's normal, that's expected, because it's showing the UVs from the diffuse textures, and it's not made for that. So you get these red lines, it doesn't work. But if I set the channel to channel 1, I show the light map UV coordinates instead, and that looks correct. I could generate these in Unreal, by the way, if I want to, but it's usually just better to do this in Maya or something. And I'm going to set light map resolution by default to 1024. And that's done. So that's cool. Collision tow. I can press collision here, but if I press it, nothing happens. It has no collision at all. It has no collision because underneath the material here, it says enable collision. That's off. So that's cool. Let's enable that. At least now we get this. But that's still not a collision. That's the collision of the model itself. For example, if you have projectiles, like if you fire a gun, the gunfire would hit these polygons. But the player wouldn't. We split it into 2. So all the character physics and all that wouldn't hit this at all. Also the physics, the entire physics model basically wouldn't hit it, but the ray tracing from code would hit it. That's the difference. And what we need to do is we need to add simplified collision. So in the collision menu at the top, there's all kinds of options you can use. For example, you can add box simplified collision, which adds a box around it. The bounding box basically becomes a collision. And you can move this thing as well, and you can duplicate it, and you can scale it. I mean, you can do some extremely basic modeling and try to make a collision model with multiple boxes that are scaled and rotated until you have something that works. It's not ideal. You can add a sphere as well, but again, it's maybe not the most suitable for a room, I guess. So that doesn't work either. You could do one of these other options, but they're just different shapes. This is, for example, a cylinder, and it will then match the cylinder points to the object. So it tries to wrap the cylinder points to, to follow the object. But none of this works because it's a hollow object. This would work perfectly fine if it's not hollow, right? But since we want to walk into the room, none of this works. I'm removing all of this. There's a third option, by the way. It's called auto-convex collision. That's the stuff here on the bottom. If you press that, it's going to try to generate a collision that matches it. But neither that won't work either. In fact, what it works very well for is this. This is the, if you have a car, like a police car, you can see the blue line there. That is the convex collision. It works very well for that. It works well for a rock, or I don't know, a tree, or any object like that. But for something that's hollow, nope. You'll see when it's done. When you have a room like this, the best thing you can probably do in production is to do the collision in Max and Maya, to actually do the simplified collision model in a 3D program and import that into Unreal, not generate it here. But I'm not doing it here, but you can see what I did here. So it generated these kind of shapes, and then it tries to wrap it around, but yeah, you see. So I'm going to do something very simple, actually. I'm going to simply say that the collision complexity is use complex collision as simple, and that will simply make every single polygon collide with me as a player. So I'm done. Okay. It's a little bit heavy. You don't want to do this if you have like a real-time strategy game with 10,000 soldiers. You probably don't want them to collide with every single polygon in the world. But for a single player game or so, you won't notice a difference in performance. So then we have the material. So the material is missing. I'm going to import a texture for the material. That's just a normal map. So we support most formats, PSD, bitmap, PNG, TGA, all that. On import, when you import it, it will get compressed to DDS for PC, DirectX, texture compression, and then here we have the normal map. You can zoom in on it. You can see it's very just normal map with a bit of noise. A lot of options here. Most of them you can ignore. The only thing you should probably pay attention to is that most people forget to set the texture group. Almost everyone forgets this, even experienced and real users, and it's not really correct. This is the texture categorization. The engine has to be able to differentiate between textures for example, the world and for the menu. So when you downscale the texture resolution in game, when you have like an options menu, say low texture detail, you don't want your menu to become blurry, right? So you have to be able to differentiate and categorize it, and that's going to help the engine for other things as well. So make sure you set this correctly. Most of these don't do anything really by default. You know, I could set this to vehicle world normal map, and it's probably going to look about the same. You know, it doesn't do much, but for the engine internally, or for you later on in production, it gives you a way of saying, oh shit, we're way over memory. Let's just downscale everything of category X. Now we have it categorized, it will help you. Either way, texture is there. Let's make the material. Right click, new material. Mod wall or so, and I mistyped that, but it's okay. Drag the normal map in there. It's all PBR. So for example, if I add just a color with number 3 on the keyboard, it's a constant 3 vector. Connect the base color here, and we have simply, you know, you could say for example, oh, it's bluish. Then we have that, and you could say, well, roughness is 0, then it's going to be reflective. Again, it's full PBR. I'm not sure if you can see it on the projector, but it's reflecting the sky now. It will reflect the actual level in real time. If you place it in the level, not sky is just preview. So that's cool as well. You got some other options here. Let me just show you a couple of basic things. I could, for example, connect the normal map to normal and then animate it. Because now it's, you can see it has a bit of a normal to it. But if you animate it with a panner, let's say it's speed 0.01 or so, and then you can always scale it as well. You can see now it's moving. Let's scale it with a texture coordinate, and this will make it bigger, scale bigger. It's just a scaling the tiling of the texture. So then I have that, and it's waterish, right? That even shows up properly. And in fact, you could have 2 of these. Just to, it's not useful for a wall, but just to play around with this. Blend the 2 together. If you're going to blend a normal map, by the way, use blend angle corrected normals, because it does a better job than simply adding 2 normals together. It does it more mathematically correct. And then use the result of both of these, except one of them is moving in a slightly different direction. And now you have simple water, I guess. Although, I don't know. It's very simple, but still, it's fun to just play with it. So let's make an actual wall out of this and not a wall of water. So let me kill this, kill the panner, kill that and that and that. This goes back here. This goes there. Roughness 0.6, so it's a bit reflective because of the paint on the wall, and the wall is mostly white, yellowish, something like that. And now I have wall. Save that. So assign that to the wall here, and we have wall. Cool. That's done. Next, next, next. Let's very quickly do this for the floor. So enable collision. Collision complexity, use complex. Resolution 1024, and floor is floor. And that's done. So cool. Save. Move on. I'm going to do new level. Entirely empty scene. So completely empty level. I'm going to drag these 2 in, and I'm going to put them on 0, 0, 0 in the middle of the world, so they also snap together if I do that. And because the game has a toy plane and you're flying through it, I need a much bigger scale than normal. So I'm going to scale everything to scale 4, so it's bigger, so I have more space to fly. And then I'm going to build the rest of the level in 3 steps. The first step is going to be the most basic objects. I'm going to do those by hand to show you the workflow, and then I'm going to speed it up in 2 different ways. So the most basic stuff first. Let's start extremely basic. We have a box, and it's called black box, and it's black. It's very black. Okay, it's just to block the light from coming through the walls. So this is just a light blocking mesh. So that's done. Then let's see what else we have here. We have the 2 couches, couch. We have a curtain. You only have 1 curtain. They're very poor. They spend all their money on a very big, expensive apartment, and they couldn't buy curtains anymore. So we have that, we have the window from the balcony, and we have the balcony railing. I think that's about it. Let's place these first. Oops. So door, that. I'm going to scale everything to 4 to begin with. So it's the right size. And then let's place it. The thing with Unreal is it has a background as a level editor all the way back in the 90s. So the level editing tools for doing things like this that works super well. I don't even use these arrows, by the way, the gizmo here. If you press spacebar, you cycle between them, by the way. I don't even use them. I use shortcuts. If you hold Ctrl or Ctrl plus Shift in combination with one or both of the mouse buttons, it moves. See, if I do Ctrl Shift and then the left mouse button, it does this, and the camera will stick to it. If I only do Ctrl left mouse button, the camera will not stick to it. But this allows me to very precisely align it with a wall, see? I would never be able to do that using that, because then you'd have to place the camera like, I mean, it's not the same as just being able to say like, yeah, I'm going to be here and I'm going to just move it, see? So a lot of those very subtle small things are built in to speed up production. So I'm just going to place these doors. So that's one, duplicate it. You can just copy paste it, Control C and V, or Control W is also duplicate. Or you can Alt drag it, which is usually the nicest thing to do, I guess, and especially in a case like this where you want a straight line, you just Alt drag it, like I did now. Cool, couch. Somewhere there. I'll have to tweak it later on anyway. This somewhere here. That's there. Their single expensive curtain goes there, so they can close a little bit of the windows. Cool, and then we have the balcony. We're missing the balcony floor actually, so let's bring that in as well. Let's see where the floor went. Here's the balcony floor, again scale 4. So that's the floor, that's about there. Then the balcony above you, so just duplicate it upwards. And the balcony is beside you, so just duplicate it sideways, rotate. So balcony, balcony. We have the railing here. The railing has this metal plate at the bottom, so just rotate this around. And again, if you talk about level tools, everything is snapped to the grid by default. That's also why it snaps here, for example, and it snaps correctly to, it's very hard to see with everything is whitish, but it snaps correctly to the side of the balcony. In fact, if I were to do this and duplicate it sideways here, it's also going to snap correctly there to the next piece. It's all just snapping together because of the grid settings here mostly. See, these are your grid settings here. You also have rotation and snapping, rotation and scaling grids, and you can change these in the preference. But either way, we have a modular workflow set up here, modular mesh pieces we can move around. Okay, balcony. We need a sky, and then I can move on to automating more of it. So we have a skyline background. We have that, which is city. Oops, wrong button. So the city, it's going to be a little bit bigger, like that much bigger. And let's move that out. Apparently this is Frankfurt. I just was in Frankfurt before coming here and they told me it's Frankfurt. So now after doing this presentation like 50 times, I finally figured out this is Frankfurt. So looking at Frankfurt. Try to guess the perspective by judging the top of those roofs there and try to position it in such a way that you can never see the edge of it when you look out of the window. Something like, bring it a bit closer again. Yeah, it's good enough, so I'll leave it at that. Also, by the way, lots of small little stuff. If you want to fly back to the level, I mean, I'd have to actually fly back, but you can do camera bookmarks, right? You can simply do Control 1 or Control 1 to 9, and if I then press just 1 again, I instantly go back. It's very easy to do all those kind of small little things. Either way, it's kind of dark outside. So in the content browser, in the bottom right, you have two things. You can do Show Developers folder, and you can do Show Engine Content. And these are two things most people don't enable. It's a bit of a shame. The developers folder, you can see I got it here now, it automatically gives you a folder with the name of your computer account. So in my case, I automatically got that. So if you're a team of people, this will automatically fill up with the names of everyone in your team. And the folder is meant to be a work folder or like a test prototype, mess around folder. It's your personal, this is where you place temporary or test files. So they don't clutter up the actual project. It's not very high tech, it's very simple, it's basically just a folder structure, but it's still nice. But in the engine content, we have everything else. Right, this is basically the engine and the editor itself, with many very useful things, such as that. Yeah. But among a lot of these are just icons and such in the editor, but among all of this, we do have some basic skies. So here's a sky. Put it to 0, you can see it's just a sphere. And we'll make it a little bit bigger, like 2500 or so, big. And you can change the material on. I'm not sure if I'm going to find the right one. It's always a bit of a search trying to find the right material, because I always forget which one is which. That's transparent, that's not it. That's transparent as well. That was a mesh. So yeah, I always forget which one is the problem. Try a different one. So you can also make this yourself, of course. It's basically just a sphere with a texture on. That's a little bit more complicated than that, but still. No, I don't seem to find it again. Ooh. It's not really the right one either. Hold on, let me just see what I have. One last try to find it, otherwise let's just go back to something. Ooh, I found it. Cool. So, clouds, just a normal standard sky. You can look at the material if you want to. This is how it actually looks. This is the material instance. And underneath that we have this, right? But you can change these things as you want. Okay, so let's move on by speeding up the rate. I don't want to place all the other detail by hand. It will take a long time. So what I did is I prepared this earlier in Notepad, because why not Notepad? Best tool ever. I did Control A, Control C, Control V. I have stuff. So, let's readjust it a little bit. So everything in Unreal will convert to text, blueprint included, right? I take this table, for example. I go back to Notepad. We just paste it in. This is my table. You can see here it says coffee table. So this is the position as well, location. So I could do X is no longer 39, but it's 539. Control A, Control C, Control V, table is next to it. It's just text. The same goes for blueprint and other things. Okay, I could do this. I could have done this in blueprint as well. You could have just easily, open up one of these other things. Just take something here and do the same there when it finally loads. Come on. Probably shouldn't have taken that. You could just take that, and then again, it's literally just text. Here's your blueprint. So, yeah. It's very easy if you work in a team, just copy paste to each other in a chat channel, and you can copy paste it directly from the chat channel in your editor, and you have the same stuff, as long as the asset references are untouched. Anyway, that's one way of doing it. It's still not enough. I need more details. So here's the other way. Levels. There's a window called Levels, and in Levels I can do add an existing level. And I prepared this in the past, so I made a level called Level to Merge. I'm going to merge that in. And I'm going to then actually right-click it before I'm done with that and do Always Loaded. Otherwise, when I play the game, it wouldn't be there until I script it to be there, which I don't want to do. So, Always Loaded. As you can see, we have more stuff now. So what just happened is that this is a separate, this is what I brought in. There is a separate level containing only this. It's a completely different file. And that gets merged at runtime with this level. So the combination is now that. It's basically a layer. Okay, you can use it either for a layering system. So for example, every room in the house is a different level. So you can have multiple people in the team work on this because, well, it's literally different files simply. Or you can organize, you can say this is the light layer and this is the sound layer and this is the gameplay layer, right? It's different, and again, they all get merged together. Or, and this is what it's actually meant for, you can use it for level streaming. So while during gameplay you don't get loading screens, but it loads in part by part. So you divide the whole game up in many small little levels, and you can pull in level per level as you're progressing through the world. You can also do that. Anyhow, I'm going to make the precision level the master level again, I mean the current level. So I double click it, you can see the text goes blue. That's the currently active layer. So I'm just making sure I'm in the right layer, and we're done with that. Cool. Do you want Lego? Lego? So I have Lego. They're very, very simple, extremely low poly, but it's just a cube with a normal map. I have 4 versions of this, which is just basically the cube in different orientations and combined with 2 blocks and all that. They're all blue, but in the material, I'm using the foliage system random value, because every instance gets a random value assigned. The random value is used to select 3 different colors. So when I start using this, you're not going to see them being blue, but you're going to see these 3 colors because of that. So I take my 4 different versions of that. I go to the foliage system that we use for painting grass and all that, and I drag them in there. Now you could change the settings of that. If you click them, you get a lot of settings here, but I'm simply going to stick to the defaults. They work in my case. And I'm going to change the paint radius a bit, go full screen, and we have Lego. So, and they with lighting, they'll look better than this, right? You don't see the normal map without light. Now the kit that lives here is terrible, so it's right behind the door. And it's everywhere. It's like on top of the closet. So 6 years later, you still find goddamn Lego. It's super annoying. And more here and there, sure, why not? And there and there and there. And in the couch, so when you finally want to go sit somewhere, you can't. And it's on the table. And the nice thing actually with the foliage system is that you can select the individual things you add. If I select the select tool, I can select each and every one of them individually and move them. So if I want to tweak something, you can. It's not just randomly scattering it. You can tweak the position and the rotation of each and every one of them manually. It's floating now, but I'll leave it be. I have to change the grid setting. So now you have it in your coffee as well. So Lego, that went fast. Then I need to start moving on to the light, but I have a couple of preparational things I have to do first. So one of them is a player start. The player start is where the game starts the player. It's just the default start location, and I set the rotation here now to be facing in the right direction. So that's easy. Another one is called a light mass importance volume. So we have a volume tab here, and anything in a volume is different, right? So a volume is obviously, well, it's a volumetric 3D shape. Within that 3D shape, stuff is different. For example, the color correction is different, the post-processing is different. I don't know, maybe it's water inside there, maybe there's invisible collider there. It's just different. In this case, with a light mass importance volume, you have to make sure it's as big as the level, so you can change these numbers to do so. But it's a little bit annoying to guess the numbers. So I'm going to use a geometry editing tool, and I'm simply going to just drag it out, basic modeling style. It's a bit easier to do, so it has to be bigger than the playable area. Within this box, and you always, if you have a level with static lighting, you always must have a light mass importance volume. You can do it without, but you won't get the right results. Within the box, you will get higher quality lighting. So this is telling the engine, please spend your rendering time on this section. The rest is less important. Everything else will still get lighting, but it will be low quality lighting. Okay, so this is the high quality lighting location box. And it has to cover the level as mentioned. It doesn't have to be super precise. Obviously, the bigger the box is, the longer the light baking will take. But the difference is pretty minimal, especially for a level this small, so whatever. It's fine. So we have that one added. There's another type, and it's called, well, actually, we have a bit of time, I think. We can add a light mass character indirect detail volume as well. That one is very similar, so let me make it as big as well. And what it does is it adds the indirect lighting for dynamic objects. So the problem is, I moved it. The problem is that when you bake the lighting and you move through the world with a dynamic object, let's say the player model, right? The character is running through the world. The character wouldn't be able to calculate how much indirect lighting there is in a certain point. He would only be able to calculate the dynamic lighting, right? So the character would lit up. If there's a dynamic light here, my face would lit up on this side. But that side would remain black because it wouldn't be able to calculate the bounce lighting in real time. And to overcome that problem, what we did is that we populated the entire world with a grid of points. So everywhere across the world, every meter or so, there's a point floating in the air. And that point remembers, at this location there is X amount of light. At this location there is X amount of light. At this location there is X amount of light. And the light you see on our characters, anything that's dynamic, is a combination of the dynamic light that he can detect in the world, blended with those pre-baked light positions. Those light positions, however, are only placed on the ground by default, because we expect most games to be, a character running around on the ground. In this case, I have a game where I'm flying in the air, meaning I would be above those light points, so he wouldn't be able to detect the points anymore because they're too far below me. And in order to solve that, I'm placing this thing called a light mass character indirect detail volume, which increases the density and the placement of these light points. So it's also going to place them in the air, basically. That's the one thing I'm after. I want to make sure that this is in the entire room. I can't show these points yet. I have to bake the light, but I can show you later on. So that's here. And it's in the air. So this, again, if you do this in a game where you can walk around, you probably want to do this for like an elevator is a very good example, because the elevator would also take you away from these points, because they're only on the elevator ground, right? So you would have to, the entire elevator shaft would have to be filled with these points, ladders, anything that takes you from the ground away should have these kind of volumes. Which again, most people don't do this. And then there is a post-process volume. Let's see where it is. Post-process volume. This one is a little bit different, as in I don't have to make it the size of what I want to affect. There's actually a property here that says unbound. If unbound is true, everything is simply affected by it. In the post-process volume, we have a lot of different settings. It's really a lot, as you can see. It's about 150 or so settings. And it's everything to do with post-processing. Now, adding the volume doesn't mean I just enable post-processing. The difference with Unity is, for example, that in Unreal, the post-processing is active at all times, all the time. I already had bloom, but adding the volume allows me to change the bloom, but it didn't give me bloom. Okay, there's a very important difference. This only exposes the settings for me to edit with. So if I switch to lighting only, and there is no light yet, so everything is dark except for the window, which is, that's obviously bright. I can try the bloom, and I can say, for example, okay, well, bloom 500, and now it's next gen, so that's cool. But I can mess with it, but it's already there. Okay, that's the most important thing. So a few things I have to set here before moving on. Minimum and maximum brightness is going to be 1. This is the exposure. And then I scale up the exposure bias to 3 or so. So this is the general brightness of the scene. The bloom is okay there. I can do a dirt mask, just for fun. So I can import this PSD, which is camera dirt. This is a case, by the way, where I should have changed this to FX or something. Just make sure it doesn't downscale that when the world detail goes down, but anyway. So you have that here, dirt mask, and we can say dirt mask intensity 500. It's a little bit extreme, but you can see it blends where the bloom happens, you get dirt on the screen. If you do it a bit less, you get that, and maybe it should probably be even less. I'm not sure if you can see it on the projector anymore, but it's subtle, but it kind of works. So that's post-processing. There's lots of other stuff we can do, but I'll move on. And then before I can do the light, the very last step is I need some reflection things prepared for. If you look on the ground, there is reflection. That's our real-time reflection that gets calculated during the game. It has a couple of limitations. You can see if I move the screen away, you get a bit of a black thing there. That's very typical for our real-time reflection. So Unreal takes a blend between real-time reflection and pre-calculated reflection. So it saves a cube map at every given location that you wanted to save it at, and it will blend the two together. That's what I haven't done, so I'm going to add a sphere reflection capture actor. And this thing, it saves a picture, basically a cube map, at this location of the whole world, and any object that's within its radius, because it has a radius there, will blend that in together with whatever other reflection actors are nearby. It takes a combination of all of the nearby ones, right? So the range, I'm going to set it to 2000, so it's a bit smaller. And then I tend to place it near either very bright objects, that's going to cause reflections, like the window in this case, or things that are just to need good reflections like a TV because it's very flat and reflective. Or I also place it in locations where you simply need a fallback one. So I'm placing one in the back of the room as well to make sure that the door, for example, doesn't have the TV one as the nearest reflection actor because, I mean, it's going to mess it up. So it needs a fallback one that's kind of neutral. So it's going to take this. You kind of want to spread it out, basically. They get heavier if they overlap. So what I did here is I have 3 of them overlapping, and that makes them a little bit heavier. The pixels that are overlapping gets the heaviest. If you have like 10 or so overlapping, you might start noticing it, but it's not super heavy. But 10 about is kind of my limit, preferably less than 5. If you have many of them in the level, it will also cause the loading time of the level to go up. The picture they save, the cube map they generate, it gets generated every time the level loads. It doesn't get saved into the level itself. So you have 100 of them. The moment the level loads, he has to go through 100 of these actors and recapture all of them. That takes a few seconds, possibly. Good. And there's more advanced ones, by the way, as well. You have planar reflection that you can add. You get higher quality reflections from that. You can also increase the reflection resolution in the rendering settings and so on. There's lots of stuff you can do. Either way, we're going to do light. Save that. And let's add a light. I'm going to do pretty much every type of light that we have, almost, and several of the advanced features in the 15-ish minutes I have left. See if that works. So here's a spotlight, and let's start with that. Switching to light mode, you can see here, obviously it's a spotlight. I'm going to place it on these 3 lamps we have here. I'm going to rotate a little bit towards the wall so the light is a little bit more pronounced on the wall. And we can mess with the settings. So I'm going to turn the advanced options on. I'm going to say inverse squared fall off is off. It gives me an unrealistic light fall off range, but it does give me more control. It gets a little bit bright if I do that, because it takes the brightness calculation gets done differently. So I'll scale it down by 1000%. Now we're back to where we were, but with a different, I get more options available here. And the range is going to be like 2048 or so. You can see it lights up that. Maybe it's a little bit less white or so. And that's okay, I think. But it's kind of boring. If you look here, it's very, very simple. So we have a feature built in called IES textures. And if I take that and I add one of these IES textures to it, you get a certain, let's see if we can take one that's maybe more obvious. It adds a certain richness to it. You can see you get this banding in the light. That's not very obvious either. Maybe that, as you can see there, that's the banding. You can generate these IES textures with free tools. So there's lots of free tools. Philips uses this as well for their actual real lamps. So this is not a game technology, this is actually real world tech. And I'm going to set mine to complex, and I'm going to scale down the intensity a bit. And the bloom is a bit extreme as well, by the way, but whatever. Duplicate this 3 times. Just going to scale down the bloom for a second. Except my keyboard decided it should become Swedish. Okay, so we have the 3 lamps, then we want to have the sunlight. So here's the directional light, which is the sun. It affects the entire level. It doesn't matter where I place it, but I usually place it near where I expect it to be. In this case, the window for me equals sunlight, so I'll place it near the window. It has an arrow, so you can see I can just rotate this. And I'll rotate the sky, the sun towards the TV a bit, so it kind of compensates for the light on that side because of, it spreads the light out. I make this slightly less bright and I make it a bit yellowish. Very, very, very faintly yellow. So I have that. It's very realistic. It says preview everywhere, so ignore that for the time being. And then we have the next issue is that everything is very black. So we add a skylight as well. Similar to the directional light, it affects the entire level, so it doesn't matter where you place it. And the skylight captures a picture of the distant geometry plus the sky, and that cube map then gets used for the lighting. So it takes the actual sky itself for the light. If the sky would be orange on one side and blue on the other, you get blue indirect ambient light on this side, red ambient light on that side. It actually traces the color of the sky downwards. So in this case, you won't see much of that because the sky is pretty uniform color. but it lights it up a bit. And it doesn't do it very well right now, but that's okay. We're going to bake the light later. A few small settings we want to change. We want to change, for example, lower hemisphere color. I'm going to set that to something not black. So we have light bouncing from below, which is realistic because we're in an apartment and the city below would bounce light back up. And I'm going to set intensity a little bit less, maybe 0.5. And I'm going to leave it be. Now I'm going to put it to static. There is three things here, static, stationary, and movable. If I put it to static, this goes for any light in any object, by the way, it will get baked entirely. So it's 100% baked into a light map. If I put it to movable, it's 100% dynamic. If I put it to stationary, it's however the blend between the two. It's going to be partially baked, partially dynamic. The problem with a static light is that you don't get very strong normals. I mean, reflections aren't very good. It's just baked in, right? It doesn't look very good for like a normal mapped surface. You know, the characters walking through it won't get very good lighting. They'll fall back on those light points, but they're not the same quality as having an actual real-time light shining on a dynamic object. They can, however, get the best quality going in terms of bounce lighting and all that, which you can't do with dynamic light. So there's very clear pros and cons. Stationary tries to combine that. It tries to blend a dynamic light and dynamic shadow with the same values on top of an already baked light and shadow. Either way, long story. In this case, I'm going to put the skylight to static. We don't need to do anything with it, just bake it in. That removes it again for now. It'll come back when we bake it. And we'll leave these things be at stationary because we'll get some better shadows by doing that. And the sun is also stationary, and that's fine. You can also only have 4 overlapping stationary lights, by the way. But that's good enough in this case. And before we bake this, I'm going to go to world settings, and I'm going to change the general light mask calculation settings. So I'm going to say it's going to do 5 bounces. It's going to enable ambient occlusion, and it's going to say set this to, I think, 0.65. 06505. Let me just verify my own picture here. There's a lot of settings to remember. So what I have 005, 065, 60. Okay. I think I didn't forget anything. You want to bake the lights? Yeah, that was so enthusiastic. Build lighting only. You can set the quality here, but I'll simply stick to preview quality. It'll be good enough. And let's just do that. So when you do that, it starts as a swarm agent. In fact, here's a swarm agent. This is it's completely multi-threaded. Not for the first step, and when it does the heavy work, it's 100% multi-threaded. You can see the different cores you have here. You can see these are my different cores, the little lines here. And if you have multiple computers, you can hook them all up, so it's a distributed renderer as well. You can set the number of cores it uses in the advanced developer settings. It only uses 6 out of my 8 cores right now. It does that by default. So if you want maximum calculation, you want to change these settings a bit. But it's going to go very fast. And that's the thing also with Unreal. We've done light baking since like 1995. It goes very fast on a laptop even. I mean, it basically just works. It almost never crashes, never runs out of memory. It simply works. We have a very good progress bar as well, which stays 0 for a long time. Then it'll go super slow from 0 to like 10%. Then it'll do 10 to 100% in like 1 second. Then it'll freeze at 99% or something again. And then it'll go to 111%, and then it's done. So that's what's going to happen now. You can see how slow it goes. Just pay nice attention to the progress bar. It's 2% now, 2.3%, 4%, 5%, 6, 7, 8, 9, 10, 12, 14, 16, 18, 20, 70, 99.72. Now we're stuck at 99. Still stuck at 99. And then the 1 second before it's done, it'll be 111%. Very, very briefly. So now it's 100. And it's probably going to overshoot it soon. Maybe not this time. It has to convert the textures back now. I mean, it has to take the results and bake them into the actual textures and compress the textures. Oh, it didn't go to 111% progress. So now we have that. It's not perfect. I mean, I did this fast. You didn't tweak it a lot, but it's pretty, I mean, I think it's decent. So that went fast. In fact, I can fly through it now. I can just do this world settings. Actually, it's the same project. Yeah, I can just do this, I think. So now we can fly. Fly underneath the table. So yeah, room. I can do one last thing, and I have 7 minutes left and some questions. Do you want to have a disco ball? I live in Sweden. Everyone there has disco balls and listens to ABBA all the time. So I think you need to have a disco ball in your apartment. Okay? I can show you the light points, by the way, mentioned earlier. Now that we built a light. See, this is what it places. See, and that's within that box that I placed. These are the points it's sampling. And each of those points is remembering the indirect lighting that was baked at that given location. And that's being controlled by that box and some other settings. Okay, so very quickly, last step, disco. So I have a simple mesh here. It's just a sphere, it's just a normal map, and the normal map is simply, panning by. We have this holder on the ceiling, and we place it on that thing. I'll just do it roughly, I mean, it's good enough. The holder, by the way, is very creative because it's actually a lamp. In fact, it's 2 lamps because I needed the second one for the top. So that's 2 of your lamps there. This thing, it's set to static. I don't want static. I'm going to set it to movable because I don't want it to invalidate the lighting. Any object that's static will be baked into the lighting. You change anything to it, it's going to invalidate the light. So I'll set it to movable. And I'll turn off cast shadow just because it's going to help me later on. Then we'll add a spotlight again. You can see this one gets across through it because I have too many stationary lights. I'll just put it to movable, and I'll just leave it be, I think, or I can turn off cast shadows for a second to make it easier as well, and lighter. And we want the reflection of this. That's the hard part. We want this to look as if it's actually reflecting the light. It's going to be faked, but at least no one will notice it. Fake is good. So let's go to where my folder was. New material. Call it Minsk Disco. I'll open up the material, and I have a texture I need as well. Which is this thing. So I made this texture. Again, it's an approximation, but I'm trying to get the reflection which is most concentrated near the ball, and then it gets more diffuse and spread out further away. We add that to the material. We say it's emissive. So now we have that, but it has reflection on it still. I mean, it has lighting on it. So I'm going to take the general options of the material by just clicking in empty space, and I will get the bottom left here. Material domain is not a surface, it's a light function. That will kill every option I have, so you only have this. Then we rotate this thing. So it's actually rotating as well, so now we have that. And then we'll blend this on top of the lights. So we have the lights here, and the lights has an option called light function. Add that there, and now we have the combination of the two. See, it's nicely blending on top of the wheels and everything else. So given I have that, let me take away use inverse squared fall off again. Let's set this to 20 or so. Let's set this to 80, 85, so it's a bit wider. Set the range to 3000 about. And then two. It's going to be hard to see possibly on a projector. Maybe a bit more even. Sorry, I did this wrong. So you get more of this, see? It's too bright now, I'm exaggerating it a lot, but you get to, it kind of fakes the lighting from it, and then you could easily just do it again and duplicate the other one up around. Now the rotation is not going to match, I would have to flip the rotation of the upper one. But if you tweak this a bit more, it's quite easy to get this to look more proper than what I just did. Okay, and see, you get this nice lighting effect going on. And it's very bright, but details. Cool. Any questions or any final requests or anything.
Do you have any questions? No? Yeah?
Hi, thanks for the lecture. Just coming from a Unity guy. So, if I'm right, Unreal places light probes everywhere on a level automatically.
Yes. Everything within the light mass importance volume, actually. So it's a combination of both of those volumes I placed. The first one I placed forces higher quality lighting and the probes in there, but only on the ground. The second box will then force the ones that are on the ground to also go up in the air. It's a combination of both.
Thank you.
Any question? If you have a trouble, I can try to translate the question for you. So you can ask in Russian. Okay. I have some kind of question. As I see, Unreal has a really big class and components library in comparison to Unity. How much time usually new people, especially artists, how much time do you need to start implementing something in blueprints? For new people, for artists especially, how they can just find functions and, that they need and so on.
You mean there's a lot of things in Unreal, of course, and it's kind of intimidating or a lot to learn?
Yeah.
Yeah, it's a bit the general thing with Unreal. I mean, Unity, if you take Unity then, it has a different approach where it's very easy indeed to get into, and then you start noticing all the stuff it doesn't have or that doesn't work well, or then you start noticing all the problems. And we kind of are the other way around, where we have a lot of stuff, but it's also more intimidating to get into it, because now it's like, oh my god, I have to learn all of this and there's so much to do. But once you're through that, it will get a lot easier and it gets very, very good, further down the line. But it's different. So what you can do is, look at all the samples that we have. That's what I would do. All of these things, go through it, learn from that. We have a lot of YouTube content. We have training Twitch streams every Tuesday. I mean, we have lots and lots of support there, game jams, internal game jams, everything. So there's a lot of channels there to learn it. There is, of course, a lot of things to learn, but we've done so much, focus testing and user interface testing and all that. With Blueprint, context sensitive, so you just drag from it, and then you only get the options you can actually do on that one thing. So it's still a lot to learn, but we feel it's more manageable. You can see the Blueprint execute in real time, right? You can see how it goes through the logic, so at least you can kind of get a feel for, oh, that probably didn't work for that reason, and so on. So.
Okay, thank you. And again, as I see today, it's even some kind of joke, like compiling shader. How much time you spent on just waiting for shader compile, for scripts compile, and so on?
If you do C++, it can take a while. If you have a large project, it can take a few minutes. But that's the biggest delay. Blueprint, unless you do extreme blueprinting, then the compile will be within seconds, 1 or 2 seconds. I built my game 80% blueprints. It has really tens and tens of thousands of blueprint blocks. That's like the worst case scenario. I will spend about a minute compiling my blueprints. But I also did some mistakes there. If you have blueprints and the blueprints are referring to other blueprints, right? So every blueprint has a reference to another blueprint. I'm compiling this one, it will just spread the compile out, right? There are ways of working around that. For example, instead of having direct reference from blueprint A to B, you could send them first to C++ and C++ onwards. Like there's a bridge between there, and therefore the compile time would be way shorter. I mean, if you can work around it. But for everything else, a material editor, no matter how complex I make the shader, it's not going to take more than, let's say, 5 seconds or so for the material. So.
Okay, and maybe I missed that, but can you still edit blueprints while light mapping?
While the game is running, or?
Yeah. While I mean, you start baking the light. Can you still use blueprints?
Yeah. While the light is baking, you can just work on. You just have to be a little bit careful. You don't change the level in such way that the lighting that is currently baking would then be invalidated by your change you've done in the meantime. But blueprints wouldn't do that, so you can totally work in blueprints. You can't edit blueprints while the game is running, but you can edit the values. So if you expose some of the values as like a variable, that's a public variable, that public variable can still be changed while the game is running. So.
Okay. Any other questions? No?
Cool. Well, thank you.
Thank you.